Algorithms, pseudocode and flowcharts. So an algorithm can be written as pseudocode or as a flowchart. Okay, and the idea is that they're quick to write and easily converted into a programming language. And that could be any programming language that you know. And there's numerous ones, but the idea is that it isn't dependent on an actual programming language. It's more like a structured English, and it should read like English. However, AQA, being as they are, insist that we do things in a certain way. So when we assign, we use a leftward facing arrow. So A is assigned the value 1, user input is wrote in capital letters, while is wrote in capital letters, and if we open up a while we have to end while. If we open up an if, that's all in capitals as well. So but an instruction is usually written in capital letters. That's the best way of thinking about it. In a flowchart, we've got certain symbols we have to use for our stop start, our diamond for a decision, our inputs and outputs, and a process is a rectangle. Inputs and outputs, that's a parallelogram. There we go, that's the word. So create a flowchart for calculating tax to be added to wages. So let's just follow it through the thing for the flowchart. So it starts off, some of the inputs their wages, the actual wages it equals wages times 0.2 because that's 20%. So whatever your wages are, times it by 0.2, and it will output our actual wages and then stop. So if we don't want to do a flowchart, we need to use pseudocode. So let's have a look. On our flowchart, we were taking the wages and then times it by 0.2 and then outputting the wages. So in pseudocode, wages is assigned user input, notice the capital letters, and you're asking what are your wages. Actual wages is a variable that is assigned the maths of wages times 0.2, and then we output actual wages. Now I know in Python we use print, but remember we need to use user inputs and outputs because this is meant to be language non-specific. So how do we check if a password is longer than 8 letters? So now we've got a decision to make. Whereas before we were just following a process, now we've got a bit of a branch happening. We can go one way or another. Start. Input the username and password. Is the length of the password that someone's just entered equal to or less than 8? Yes, welcome, and the program stops. No, invalid password. Try again. It's not 8 letters. And you give them a message on the screen. So at the moment we're not in a loop. Obviously if somebody entered an invalid password we might want to loop it back around. We'll look at that later on. At the moment we're just talking about branching and splitting it in half on an if. If true, do this. If false, go that way. If yes, do this. If no, go that way. So username is assigned user input, enter a name. Password assigned user input, enter name. I wrote that wrong. That should be enter a password. Sorry. If the length, so this is our if the length of password is less than or equal to 8, then output invalid password, else output outcome, end if. So it's a very similar function, very similar layout to how we'd write Python. It's just use capital letters for your decision. Remember that end if. If you open an if, you have to end an if. Now we don't have to do that in Python because the indentation kind of shows what's belonging to what, and when we get rid of the indentation, it ends the decision. But we need to say end if to specify that we've finished doing that end if now. We've finished that rule. And there is a little more detail. I've changed the enter name now for password. It should say enter password. So let's have a look at a loop that is continually doing something. So looking for a Pokemon in a Pokedex, we'll use that example. If we start, are there more Pokemon to search? Yes. Right, we'll check the next Pokemon then. We've got our whole Pokedex. We're going to search for this rare Pokemon we've just seen. Are there more Pokemon to search for? Yes, there are. Right, check the next Pokemon. Is this the matching Pokemon? Yes. Right, well, we found the Pokemon then. We found it. End of. It's finished. If it isn't the next one, it's going to go round in a loop. And it will check the next Pokemon. Is this it? No. Right, we'll check the next one. Is this it? No. And it goes round and round and round and round and round and round. Until it finds the Pokemon. And where this is different is then on our decision at the start, and our question, it's saying, are there more Pokemon to search? Well, if we've checked everything, no, there's no more Pokemon to search. So we break out of that loop, and it says Pokemon not found, and it ends the program that way. It's bad programming to get caught up in a loop that's going on forever and ever and ever and ever. You have to have a way out. All branches, like all if statements or all while loops, should have a condition that makes it or breaks it.